did covalent bonding, and it is really, really easy. So you should have a sheet like this. We'll just go over this really quickly. Your sheet, let me make this bigger. There we go. The very first thing, some important information. I'll put a clean sheet out here so that you can see. A couple things that we did is when we learned about covalent bonding is that you can read this right here. They're compounds made from two different non-metals. So this is different than ionic bonding, because ionic bonding is a metal and a non-metal together. And that's where, remember, we've been talking about in class where you give an electron away and the other one takes the electron or electrons. This is not between a metal and a non-metal. These are two different non-metals. So we're only going to be working with those things on the right side of the periodic table, and hydrogen. So what you're going to be doing is, since covalent bond formation occurs via or by the sharing of electrons, that's important because this happens between two nonmetals. So those two things are really important right there. It says that twice, nonmetal to nonmetal, two nonmetals. So when you're looking at either the naming or you're looking at a formula, you're going to look at the types of elements that are being bonded. If you have two nonmetals, it's going to be a covalent bond. If you have a metal and a nonmetal, it will be an ionic bond. So this happens because of the sharing of electrons. And this is the other part that's pretty important. The ionic charges have nothing to do with covalent, okay? Because they really don't become charged. They're not, again, they're not gaining or losing. They're just trading spots. So what we're looking at here is we use Greek prefixes when we name these. So here are the Greek prefixes. I'll put those down. You can pause it. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, then 7 is hepta, 8 is octa, 9 is nona or nona, and 10 is deca. So pause the video and be sure you get those down, and then we're going to look at how to apply those. Alright, so down here we have some of the rules. So you're going to attach the appropriate prefix, the Greek prefix, to the name of the first element. So there is an exception. You do not use the Greek prefix mono on the first element. So we don't call CO monocarbon monoxide. We call it carbon monoxide. So if the first element is not doesn't have a subscript, so there's only one of them, you don't have to put the mono in front of the first one, but you always put it in front of the second one if the second one has just one. So what you're going to do is you're going to attach the appropriate Greek prefix to the second element always. Mono, tri, di, hexa, hepta, how many ever that you have. Then we're used to doing this, putting the IDE suffix on the second element, only on the second element. Some of these we're used to changing, because when we get down here like this one here, nitrogen, we're used to changing nitrogen to nitride. But in this case, nitrogen comes first, so it's not a nitride, it's just nitrogen because it's first. The second one is the one that you change to IDE. And then this fourth rule isn't really that super important. If it ends in an A or an O, you drop it and you bring it together. So like for example, carbon monoxide, you don't say monoxide, you say monoxide. So it's kind of just meshes those two together. It's not going to be that big of a deal, knowing that you know the prefix and the element is the most important there. So when we look here, we've got dinitrogen monoxide. So the formula, di comes from the 2, nitrogen from that first element, so that's dinitrogen, monoxide, 1 oxygen, monoxide. The second one, dinitrogen, again, 2 nitrogens, tetrahydride. Hydride is hydrogen, right? We changed the second one to an IDE. So dinitrogen, tetrahydride. And again, we are only putting the IDE on the second one, not on the first one. And then the third one there is carbon tetroxide. So tetra, oxygen, 4 oxygens. Carbon, because there's 1, you notice that's a 1 and there's not 1 there, but you assume it's a 1. You don't say monocarbon because it's first. So it's just carbon tetroxide. All right, on the back side, these are things that we name. So we did this together in class. IF5 is iodine pentafluoride, selenium monoxide, arsenic trichloride, diboron trioxide, diphosphorus pentoxide, silicon tetrabromide. So if you can see, it's the pattern. I'm doing the same thing. I'm putting the beginning one first. Notice that this one did have a 2. So boron got the diboron and diphosphorus. Okay, and the second one's all end in IDE. None of the first ones end in IDE, but all the second ones do end in IDE. All right, over here on this one, number 7 was dinitrogen, 2 nitrogens, pentoxide, carbon dioxide, you've heard of that one, diboron hexahydride, 2 borons, 6 hydrogens, diboron hexahydride. Dihydrogen monoxide, which is water, right? Dihydrogen monoxide, and dichlorine monosulfide. Had a lot of students during the day that wanted to change this to chloride, but remember, you can't because it's the first. If it was on this side, it would be the chloride, but it's the first element, so you have to leave it there. Then we go backwards. So right here, these are examples of writing the formulas if you're given the word. So this one here is dinitrogen pentachloride. So I have nitrogen, I have chlorine. Those are my 2 elements. Then I look at my prefixes. Di is 2, penta is 5. So that's how they wind up with this formula, N2Cl5. And notice there's nothing about the oxidation numbers. There's nothing about the charges. It's just straightforward. And you don't have to reduce. I know we talked about in class about reducing some, like if this were 2 and 4, having to reduce. This is a literal translation of what you are reading. So there's no reduction here. It is just the way that it is. So let's look at selenium hexafluoride. So I have selenium and fluorine. Selenium would only be 1, right? So Se. And then hexa means I have 6 fluorines. So SeF6. Then tetraphosphorus heptoxide. So I have phosphorus and oxygen. Tetra means 4. Hepta means 7. So there's my formula for that one. So down here, phosphorus triiodide means you have phosphorus and iodide, or iodine, and you have 1 phosphorus because there's no prefix, and you have 3 iodines. Iodine, that's I, it's only 1. Monobromide, so I only have 1 bromine, so IBR. Nitrogen trichloride, 1 nitrogen. If it said dinitrogen, it would be an N2, but it doesn't. It says nitrogen. Trichloride, 3 chlorines. Carbon monoxide, I have carbon and oxygen. Carbon, there's only 1. Monoxide means I have only 1 oxygen. Sulfur hexafluoride, I've got sulfur and fluorine. Sulfur, there's only 1. Hexa means I have 6 fluorines. Dinitrogen, N2, tetroxide is O4. So nitrogen tetroxide. And this is one like if it's an ionic bond, you would reduce that, but it's covalent. So again, it's just a literal what it says. You write the numbers. And then boron monoxide. 1 boron, monooxide or monoxide means you have 1 oxygen. So there are several things to practice on after this. If you still have questions, come see me. Tutoring is Thursdays at 3:15 to 4:15. So you can come see me. You can watch this again. You can look it up on YouTube, somebody else explaining. If you look that up and you're wanting to know like Khan Academy, what you're going to be looking for is this title here. Binary, you're looking at naming binary covalent compounds. So if you are searching, you will look for naming or how to name binary covalent compounds. And you might find something else out there too. So that's all that is, and what we did is these practice pages that go along with it. There's a lot of practice just because that repetition is really, really good to learn. So that's it.